Assalamu Alaikum everyone. Today I'll be teaching you how to build a circuit using Quartus. For this tutorial, I'm using Quartus Prime. But if you have a Quartus 2, that's perfectly fine. It's work just as well. First thing first, you open the Quartus that you download on your desktop, and after you open it, you click on the new project because we're going to make a new circuit. Because I'm giving a tutorial right now. After that, it's going to pop up something like this, and you just click next. Now you're going to save the file in the place that you want to save it, so it's easy for you to access it after this. So I'm going to save this project as a basic gate. Okay, after you finish it, you're going to make a new place to build a circuit. So follow this instruction. This is a easy way. We're going to create a file and click a new, and after that we choose block diagram, and it's going to be something like this. Okay, after we done it, we will begin building our circuit for a flood monitoring system by adding an input. So simply click the gate shape icon at the top. After you click it, you're going to see something like this, and you're going to search for primitives. Inside the primitive, you're going to find a pin, and inside the pin, you're going to find the input that you've been searching for. After that, you click OK. You can also make it as a repetition, so it's make it easier for you. You don't need to go back and search it back like that. Okay, right now we're going to label each one of the input. The first input we're going to label as R, which means water intensity. And for the second input, we're going to label it as W, which means wind intensity. And for the third one, we're going to label it as L, as a water level. And the last but not least is P, as a power supply. Okay, right now we're going to adding the outputs. So how to add the outputs is the same how you add the input. We're going to add 4 outputs. Okay, for the first output we label as F, which means flood risk LED indicator. If F equal to 1 is high flood risk. If equal to 0 is low flood risk. For the second output, we will label it as flood alarm. If A equal to 1, it's active the alarm. If equal to 0, there is no alarm. For the third one is E, evacuation warning. If it equals to 1, it's issue warning. If equal to 0, there is no warning. and the last one we label it as D, which means emergency service notification. If D equal to 1, it will give a notification, and if D equal to 0, it will not give the notification. Okay, let's go back. Now I'm going to teach you how to get the gate. Okay, follow this instruction. You can pause it. Okay, first you click the icon and you're going to search for the primitive. Inside the primitive you have a logic. Inside the logic you have the AND gate, OR gate, or the NOT gate. That is the way to add the gate, but there's a faster way, which is that you just can type the gate that you want. It's going to pop up, something like that. Right now in our circuit we're going to use AND gate, NOT gate, and the OR gate. We're going to use all of the gate, but the most of the gate that we use is AND gate. Okay, this is how the way that you connect and adding the gate. You will do it one by one. You can arrange the input, output, and the gate based on what you like. It's up to your own creativity. This will make the circuit more tidy, and it's also help you to better understand of the circuit, where's the inputs goes and what's the inputs goes through and what the output of it. Okay, now I'm going to make the full circuit of flood monitoring system by following this Boolean equation. So I'm just going to speed up the video. Okay, after you done the circuit, now we're going to save it. So click the file and search the save as. After that, you're going to save the name. It's up to you what you're going to save it, but you need to save it inside the folder of the project. Okay, now we're going to do the simulation of the circuit. You go to the project navigation and click the hierarchy and go to the files. It's going to show you something, going to show you the file that you save. So you right click on the file and set as the top level entity, so you can run it. If you not set it up as the top level entity, you cannot run the simulator. It will become error. After you done the simulation, it's going to show you the result at the messengers. As you can see right now, it's successfully with 0 error but 6 warning, but it's still successful. So after this, we're going to make a simulation for waveform for this basic circuit. So you just follow this instruction and you go to the file and click new and search for University Program VWH and you click OK. Okay, I'm going to teach you how to use this. Now go to the edit and set the grid size 1 microsecond and click OK. And next we're going to set the set and time for the 16 microsecond. Okay, now as you can see the blank space on your left, you right click on it and you go to the insert the node and click node finder and click the list and change the type for so the input can be above and the output on the bottom. So you click all, you take all of it and you click OK, and now you click OK. So we're going to arrange it as a true table, so it will make you easier to understand. After you done arrange the input and output, I'm going to show you how you set the value of each input. First thing first, you click on the first input and go to the edit and search for value and try search override clock, and you can set it up as 2 microseconds. For the following input, you can go to the top. As you can see, there's a shortcut feature. It will be easy for the user to put the value of the inputs. The second input you put 4 microsecond, the third 8 microsecond, and the last one is 16 microsecond. Okay, this is the most important part. You click the simulation and go to the simulation setting. At the fourth line, you can see the word NOVOPT dash. You need to delete it and save it so you can run the simulation. Before you run it, you need to save the file first. After you save it, you can run the simulation. Okay, after you run the simulation, you're going to get output something like this. Okay, next I'm going to teach you how to change a basic gate into the NAND gate circuit. This is the formula how to change each of logic gate into the NAND gate. Okay, first I'm going to change NOT gate at the P into this NAND gate, and then I'm going to change AND gate at the RLW into this gate, and I'm going to change the last OR gate into this gate. Okay, after that you're going to get a circuit NAND like this. Okay, now we're going to save it. Just click to the file and save as. But remember, you need to save at the different folder. You cannot save as the same folder as you save the basic circuit. Is it because it's going to affect the latest project, so it's going to be an error in the future? I'm afraid that will be happen. So just save it under different folder. Right now I'm going to do a simulation of NAND circuit, so I'm going to speed it up because it's going to take a while. Now you can see it's successful with 0 errors. It's the same as the basic circuit simulation. Okay, now I'm going to show you the result of the waveform for the NAND gate and the basic gate. I'm not going to do the waveform simulation for the NAND gate because it have the same procedure as a basic gate, so it's similar. Now you can see both of the waveform simulation result is the same, particularly similar. This means that our objective is achieved. It also means that our basic and NAND gate is successful. Thank you for watching. Please share and subscribe to my channel.